Hi class, in this video we're going to continue our discussion about CFA. I'm going to begin with several examples to demonstrate that model identification of CFA sometimes is a tricky issue and provide some guidelines for you to follow in future research. Keep in mind that we follow the same model identification rules in SEM, regardless whether we're working with past models or CFA models. We need to know the value of t, the total number of parameters to be estimated for a model, and u, which is the number of unique values in the variance and covariance matrix. T smaller than u is a condition to meet when we want a over-identified model. In the first scenario, there is one latent factor with two measured indicators. We use the unit variance identification to set the variance of the latent factor to 1. As such, there are 4 parameters to be estimated: the 2 factor loadings and the 2 error variances of the indicator variables. Given that we have 2 measured variables, there are 2 times 3 divided by 2, 3 unique values in the variance covariance matrix. So t is greater than u. This is an under-identified model. Now let's take a look at the second model. In this CFA model, there are 2 latent factors, f1 and f2, each with 2 measured indicators. And the 2 factors are correlated. Again, we use the unit variance identification to set the variance of the 2 latent factors to 1. There are 9 parameters to estimate: the 4 factor loadings, the 4 error variances of the indicator variables, and the covariance between the 2 latent factors. Because there are 4 measured variables, 1, 2, 3, 4, we have 4 times 5 divided by 2, 10 unique values in the variance covariance matrix. T is 9 and U is 10. This is an over-identified model. Then I made one change to model 2, and we have the third model. Everything is the same as the previous model, except there is no covariance between the 2 latent factors. So the number of parameters to estimate is 8. The 4 factor loadings and the 4 error variances of the indicator variables. Given the 10 unique values in the variance covariance matrix, it seems like an over-identified model, but not so quick. Since there is no relation between the 2 latent factors, this model has 2 isolated parts. Each part is the same as the under-identified model 1. Take a look here, they are the same. We are, in fact, dealing with 2 locally under-identified 1-factor CFA models. In the last scenario, model 4 looks identical to model 2, with one additional piece of information. There is a covariance between the 2 latent factors, but the covariance is almost 0 due to the weak relation between the 2 factors. This model appears to be identical to model 2, but in essence, it's actually model 3. So very likely it's an under-identified model as well. It could be very frustrating when there are model identification problems. So for CFA models, statisticians have recommended the 3-indicator and 2-indicator rules. The 3-indicator rule suggests you use at least 3 indicators for each latent factor. It's a safe choice for all types of scenarios. The two indicator rule suggests you use at least two indicators for each latent factor when the latent factors are correlated. I recommend that you follow the three indicator rule whenever possible. Of course, the goal is to have an over-identified model. Would you be able to have an over-identified model without meeting the rules? In many cases, the answer is yes. The rules are recommended to reduce your chance of encountering model identification problems. If you are unable to meet the rules all the time, it's fine as long as your model is still statistically identifiable. As a second item in this video, I am going to use an example to demonstrate how to write the command file in Mplus for a CFA model. In this example, there are 4 latent factors measuring students' reading, history, math, and science self-concept. Each latent factors have 5 measured indicators. They are actually 5 questions on the instrument. One thing to pay attention to is that the same 5 question stems are used for all 4 factors, with only the subject change for each factor. For example, for reading self-concept, the questions are: compared to others of my age, I'm good at reading. I get good grades in reading. Working in reading class is easy for me. I learn things quickly in reading. I have always done well in reading. For math self-concept, the questions become: compared to others of my age, I'm good at math. I get good grades in math, so on and so forth. Because the items are shared by questions about the 4 subjects, it's expected that there are common method correlations between the error components of the measured variables. In other words, there is some systematic error in the measured variables due to the measurement method, and questions that share the same stem have error covariances. Once you have the hypothesized model and collect the data, the next step is to prepare your data in SPSS for analysis. Always get the descriptive information to check the data first. I always request for the minimum, maximum values, the standard deviation, and the mean. You can see from the summary table, the items have a minimum value of 1 and maximum value of 5. The total sample size is 500, but there are some missing data. The missing values appear as blank cells in SPSS. I need to recode them for Mplus. You need to go to Transform, recode into the same variables, and for all the variables that might have missing data, take them to the right, and for the old and new value, you want to recode the system missing into a value of 99. You can choose other values to replace the missing data if you want, as long as the value you choose is not in the range of valid values in the dataset. Export the data into tab delimited text file after you are done with the data preparation. Give it a name and save it under the same folder where you have your Mplus command file. Do not include the variable names in your data file. But as a little tip, sometimes I keep the variable names in there and cut them out and paste them into my command file. This way I can be sure that the variable names in my command file are exactly in the same order as in my data file. Save your data and open it up in Mplus to check the accuracy. I don't know why, but there are strange characters at the beginning of the file, and let's take them out. There are no variable names in this data file, and the missing data are coded as 99. Everything looks good now. We are ready to write the Mplus command file to analyze the CFA model based on the model structure as shown in this diagram. Please note that in CFA models, all pairs of latent factors are associated by unanalyzed correlation or covariances. That is why the structural part of the CFA model, as I outlined here using the red dotted line, is just identified. Having a just identified structural part of the CFA model is necessary to guarantee the model evaluation information in the output file is for the CFA or the measurement part of the model only. In this graph, the correlated error variances are demonstrated. You can see that the errors of item 1, 6, 11, and 16 are correlated because they all share the same question stem. Compared to others of my age, I'm good at such and such. The same thing happens to the other 4 sets of questions. I will put the command file in the weekly folder. Here, I would like to highlight a few things. First, we are reading the raw data file for this analysis. This is how you read a raw data file in Mplus. File is, and you give the file name. Then, format is free. For variable names, since I have sets of questions numbered 1 through 5 at the end of the variable names, I can use a shorthand by typing read SC1 through read SC5, or you can list the names individually. Remember, in names R, you need to name all variables that are part of your dataset. If you only use a subset of the variables in this analysis, list the names of the variables you are going to use following the subcommand use variables R. In this example, 5 variables not used, including the RID, gender, class, STEM, and SES proxy. And they are excluded from this list. The next line, missing are all 99, is for you to tell the Mplus how you coded the missing data. Remember, I coded all missing values as 99. In the model section, you specify the relationships between the factors and their measured indicators using the keyword by. For example, reading self-concept is measured by reading SC1 through reading SC5. You do the same for the other factors in the model. In the next part, still in the model section, I need to specify the covariances between the items that have correlated error variances. Remember that the first question of every set share the same stem, second questions share the same stem, so on and so forth. So here, I use read SC1 with history SC1, math SC1, and science SC1 to tell Mplus read SC1, the first indicator of reading self-concept, has correlated covariances with history SC1, math SC1, and science SC1. History SC1 has correlated covariances with math SC1, science SC1. And at the end, math SC1 has correlated covariance with science SC1. We have 6 pairs to specify because there are 4 items in the set. Then the same is repeated for the other 4 sets of questions. In the last section, you request the output information. Correlations or covariances between error components are not common. I'm just using an example to show you what you need to do in case you encounter a scenario in which you have to set the correlation or covariance between error components. In most cases, you do not have to do this.